All right, welcome back, everybody. Today, Objective 3 in our Algebra A review. We're talking inequalities. We'll just dive right in and get going with that right away. Here we go. So first things first, what is an inequality? I'm going to say an inequality is a mathematical sentence that uses greater than, less than, greater than or equal to, or less than or equal to symbols. Okay, so when you hear inequality, think these symbols here. And he uses those symbols to compare the values of two expressions. Okay, a lot of times in mathematics and in the real world, we want to find a single solution to a situation. Okay, that'd be why we set up and solve equations and end up with x equals some number. Okay, but in a lot of mathematical situations, along with real world situations, we're not looking for an individual number, we're looking for a range of possible numbers, and that's where an inequality would come into play. Okay, example of a quick inequality. Let's say that x plus 1 is greater than 3. Okay, so here's an example of an inequality. I've got an expression on the left side and the right side of one of my inequality symbols here. Okay, we say a solution of an inequality is a number that makes the inequality true. Okay, so if I plug in an x here that makes this left side greater than 3, for example, let's pick something huge, 42. I can know without calculating anything that this left side will be greater than 3 if I plug in a 42 for x. When it comes time to solve these inequalities, we want to come up with a range of all possible solutions for that inequality. First thing we're going to do today is look at identifying solutions to inequalities. Problem 1 says determine whether each number is a solution to this inequality. 2x plus 1 is greater than negative 3. So I want to figure out in part A if negative 3 is a solution, and part B if negative 1 is. And to do that, essentially what we're going to do is just substitute in the values for my x. So I could rewrite this as 2 times the quantity of negative 3 plus 1, and we want to know if that's greater than negative 3. Well, let's see here. 2 times negative 3 is a negative 6, plus 1 is greater than negative 3. All right, negative 6 plus 1 is a negative 5, and that needs to be greater than negative 3. Okay, that statement is false. All right, negative 5 is not greater than negative 3. It is less than negative 3. It's further down the negative side of the number line. So I'd say that negative 3 is not a solution. Okay, it doesn't satisfy my inequality. We can do the same thing with negative 1 here. So 2 times negative 1 in parentheses plus 1, and we want to know if that's greater than negative 3. Okay, again, I'm just substituting that value in for my x in the inequality. 2 times negative 1 is a negative 2. So we have negative 2 plus 1, and we want to know if that's greater than negative 3. Negative 2 plus 1 is a negative 1, and that has to be greater than negative 3. All right, that is true. Okay, negative 1 is greater than negative 3. It's less far down the number line in the negative direction. So we do have a solution. Okay, we're typically worried about finding all solutions to inequalities, but it's good to be able to evaluate whether individual values are solutions or not, like we did here. The next thing I want to do as we kind of get comfortable working with inequalities is look at graphing inequalities. So problem 2 just says graph each of the following inequalities. Part A, we want to graph x is less than or equal to 2. Okay, so this inequality represents all numbers that are less than or equal to 2, and a great way to visualize that, a great way to think about it actually even, is to sketch a graph of it. Okay, graphs for inequalities are going to be pretty simple. We're just going to make a one-dimensional number line. And as far as points I need to put on it, all I really need is a 2. We'll say 2 is here. And if x is less than or equal to 2, that means x is all the numbers below 2, so as in 1, 0, negative 7. So the way we'll graph that then is we're just going to make a shaded line. We'll shade this going down forever because as I continue down the number line towards okay, greater and greater negative numbers, I'm going to always have something less than 2. Okay, so everything to the left is 2 is shaded. Now, as far as how we'll show that we have it or equal to 2, that we're going to include 2, with our graphs, what we'll do is we'll put a solid circle, all right, on that part of the number line to show that we are including 2, we are including that endpoint in this graph. Let's do one more of these as a class here. Same idea, we want to graph negative 4 is less than x. Okay, now with this one, notice the variables on the other side of my inequality. Okay, I can have it on the left or the right. Pay attention to kind of which direction it is, though. Once again, I'm going to put a negative 4 on my number line. And when I read negative 4 is less than x, okay, that means that negative 4 is smaller than my x values. Or I could read this backwards and say x is greater than negative 4. Either way, what we'll end up with is we'll be shading everything above negative 4. Okay, my solution to this inequality represents any number that's bigger than negative 4. Now, to show in this case that we're not including the endpoint, okay, we're not including 4 because there's no or equals to here, what we'll do is we'll do an open circle. Okay, closed circles for the or equal to, open circle if it's strictly greater than, strictly less than. Okay, that's graphing inequalities. Now, notice your note guide has a part C that we're not going to do together here. Okay, we want to give you one more chance to practice this before we move on. We'll be graphing the rest of the lesson. So take a minute, pause the video, run through that problem on your own, shoot a hand up and check your answer before we move on. Okay, and then once we're sure that you're good with that one, you can hit play and continue with the video, continue with the lesson. Now, another good skill to have is going to be going from a phrase to an inequality. Just like it's important to be able to go from phrases to expressions or equations, same thing, we want to go from phrases to inequalities so we can put the real world into math notation. Okay, problem 3 says write an inequality that represents each variable expression. Okay, so part A says v is greater than or equal to 5. This is pretty simple, pretty straightforward. We can just write it as v greater than or equal to the 5. And there you go. Now, it would also be correct, we could also say or 5 is less than or equal to v. That would work as well. Okay, again, you can have that variable on either side of the inequality. Notice the inequality symbol is going to flip directions as I switch sides with the variable, though. Okay, there's a part B that's the same idea. Once again, pause the video, okay, run through that one, check your answer, and then move on with the lesson. Now, the big thing we're going to do in this chapter is look at solving inequalities. It's great to determine whether or not individual numbers are solutions to an inequality. What we really want to come up with is the range of all possible solutions. Okay, that's what the solution to the inequality is going to be. Okay, so problem 4 says solve each inequality, graph the solution. And I have an inequality here. I want to figure out all the possible t values that are going to make this inequality true. In other words, make the left side of the inequality greater than 21. And to do that, I'm basically going to do all the same steps I do for solving an equation, with one difference we'll show you at the end of the problem. Okay, so I want to isolate this t. I'm going to start off by subtracting 9 on both sides, okay, to get rid of the positive 9 on the left. That'll leave me with negative 4t is greater than 12. And then what I'm going to do is I'm going to divide both sides of this inequality by negative 4 to get the t by itself on the left. Now, the one trick with inequalities is when I multiply or divide by a negative, I do need to flip that inequality symbol. Okay, this is no longer be t is greater than something, it'll be t is less than. Okay, 12 divided by negative 4 is negative 3. Okay, so my solution to this guy is t less than negative 3. Now, this problem also says graph the solution. So t less than negative 3 is my solution. We can represent that algebraically, or we can represent it graphically. It's good to be able to do both. So we'll make a quick graph here. I'm just going to throw a negative 3 in the middle. T is strictly less than negative 3. So I'm going to shade everything below the negative 3 and put an open circle to show we're not including the negative 3. We're strictly less than the negative 3. Okay, so hopefully you're recognizing solving inequalities is pretty much the same thing as solving equations. Okay, just with that last step, if I do divide or multiply by a negative, I do need to flip my signs. Okay, part B is the same idea. I want you to take a minute, pause the video, run through part B, and then make sure to check your answer before you move on. Now in problem 5, we're just solving more inequalities. And I suppose problem 5 is maybe a little more complicated than we just did, because notice I have the variable, my n, on both sides of the inequality. Okay, but just like with an equation, what we're going to do is we're going to get all the variables on one side, okay, all the numbers on the other side, and then solve from there. Okay, so once again, solve the inequality, graph the solution. My first step here is going to be subtract 3n from both sides. And the reason I want to do the subtract 3n instead of 6n is, as much as possible, especially with inequalities, I want to keep my variables positive, especially since that way I don't have to worry about flipping my sign or forgetting to flip my sign. So if I subtract 3n on both sides, that's going to give me a 3n minus 1 is greater than or equal to, suppose on the left the 3n's cancel, greater than or equal to 8. I can then add 1 to both sides, which will give me 3n is greater than or equal to 9. And then divide both sides by 3. And we end up with n is greater than or equal to 3 for a solution. Okay, notice that time, since I didn't divide by a negative, I didn't flip my sign. We'll keep it facing the same direction the whole time. Okay, graphing the solution. Again, just a nice way to visualize things. We've got our 3. N is greater than or equal to 3, so it's everything above the 3. For the or equal to, we'll fill in the closed circle, so we include the endpoint, and then we'll shade everything going up from the 3. All right, part B is another example of an inequality with variables on both sides. Once again, pause the video, run through that, and check your answer before you move on. The next thing we're going to talk about is the idea of a compound inequality. A compound inequality is just two distinct inequalities joined by the word and or the word or. Okay, so we're going to take a look at what the and the or cases are for compound inequalities. Start off with the and case. It's good to think about these graphically. So we'll say the graph of a compound inequality with the word and contains the overlap of the graphs of the two inequalities that form the compound inequality. So for example, if I have x is greater than 3 and x is less than or equal to b, okay, in blue and green, the and case would be where they overlap, okay, everything where they kind of stack on top of each other here. Now, with the and case, we can simplify the way we write our inequalities. We can rewrite two inequalities involving and as a single inequality, such as I have here in red. We can say a is less than or equal to x, which is strictly less than b. Okay, since all my solutions are sandwiched between two numbers, two values here, I can kind of do the same thing with the x, putting it between those two endpoints. All right, so that's the and case. For the or case, we'll say the graph of a compound inequality with the word or contains each graph of the two inequalities that form the compound inequality. So here I have one set of solutions or the other. So for x is greater than b and a is less than or x is less than or equal to a, okay, I'm going to shade on my red graph here the compound inequality, basically just both parts here. All right, there's not a fancy way to combine that in a single inequality that doesn't work that way, so we'll just use the or when we express those ones. All right, now just like with regular inequalities, with compound inequalities, we want to be able to work back and forth between the expressions for them, the graphs, then also the descriptions. So that's what we're going to do in the next set of problems. Problem 6 says, write the compound inequality that represents each graph. Okay, so for each of these graphs of inequalities, I want to write them as a compound inequality with an expression. Okay, in part A, I can tell right off the bat I have the OR case because my solutions take up one chunk of the number line or the other one. So what I can do then is I can say that this bottom part is everything below -1. We'll just say x is strictly less than -1. All right, or we have everything above the 3, so we can say that x is greater than or equal to, because we have the closed circle, greater than or equal to 3. Okay, so there's my compound inequality representing that graph. I suppose I could flip both of those around and say that -1 is greater than x. Okay, 3 is less than or equal to x. Okay, but we'll keep in that order for this one. Let's go ahead and do part B together as well. Here I can tell, since I have two endpoints, since my solutions are sandwiched between two values, this is going to be the AND case. And what I can do for this is basically just put my x between the endpoints. The endpoints are 3 and -2. And then all I need to do is make sure I account for open and closed circles. Since we're closed on the -2, we'll say that's greater than or equal to -2. Since it's open on the 3, we'll say strictly less than 3. There's my compound inequality, the AND case, the overlap case. Again, we want to be flexible with the way we can represent inequalities, especially when we get into some real-world problems in a few minutes. So in problem 7, we're going to go write a compound inequality from a math phrase. So 7, write the compound inequality that represents each phrase. In part A, we have all real numbers that are greater than -2 and less than 6. Okay, so the key for this one is recognizing that we have our AND case here. So just like we did a minute ago using the graph, we'll just put x between two numbers. Okay, it's greater than -2 and less than 6. Doesn't say or equal to anywhere, so we don't have any lines underneath our inequalities. Pretty straightforward, but that's our inequality in expression form. Okay, part B is the same idea, going from another mathematical phrase to an expression. I want you to take a minute, pause the video, run through that one, and then again check your answer before you move on. Now again, an important part of this lesson is solving inequalities. So the next thing we're going to look at is solving compound inequalities. So the first set of compound inequalities we're going to look at are going to be involving the AND. So problem 8, solve each inequality, graph the solution. And I can tell this is the AND case because I have two separate inequalities on it. My variables squish between two numbers. And I'm basically going to solve this like a normal inequality, except for when I do something, rather than doing something to both sides of the inequality, we have to do it to essentially all three parts of this inequality here. Okay, so first thing I'm going to want to do with this one is cancel out this division by 2. So for that, what I'm going to do is I'm going to multiply by 2 to cancel it out. But when I do that, I'm going to also have to multiply on the right side by 2 and multiply on the left side. So that's going to leave me with 2 times -3, which is a -6, is less than or equal to m minus 4 when that fraction's canceled, which is strictly less than -2. And then as a last step to get the m by itself, I want to get rid of this -4, so we'll add 4 to the middle to cancel it out. And again, we'll also have to add to the right side. We'll also have to add to the left side. That's going to leave me with a -2 is less than or equal to m, which is strictly less than a +2. Okay, now if I did multiply or divide by a negative, I would have to flip both the signs. Okay, so something to watch for. Didn't have to do in this case. Let's graph our solution. Our two endpoints are -2 and +2. Okay, our solution is everything between the two of those. And then we'll have a closed circle on the -2 for the or equal to, open circle on the +2 to show we don't include that. All right, so that's solving a compound inequality. Part B is the same idea. Take a minute, pause the video, run through that one, and make sure you check your answer before you move on. Next thing we're going to do is looking at solving compound inequalities involving OR. So as you can see here in part A, I have two separate inequalities with an OR between them. Now for the OR case, there's no special way we can solve these both at the same time. Basically, it's just like solving two inequalities at once and then combining your solution. So it doesn't matter which one we start with. I'm going to start off with the one on the left. To get the 3t or the t by itself, I'm going to subtract 2 on both sides. That'll give me a 3t is strictly less than -9. And divide both sides by 3, which gives me that t is strictly less than -3. Okay, so that's my first solution. We'll kind of keep that out of the way. Or I'll have my second solution. Same idea, we want to get the t by itself in this inequality. Again, I'll subtract 5 on both sides. That'll leave me with a -4. T is less than -4. I can then divide both sides by -4. It's going to cancel the -4s on the left. That's going to reduce this down to 1 on the right. And then remember, once again, anytime I divide by a negative, I need to flip that inequality sign. So we could say t is greater than 1 then for that part of the solution. So in total, we have t is less than -3 or t is greater than 1. Let's graph that out. We've got a -3 and a 1 for endpoints. Okay, t is greater than 1, so we'll go open circle, shade everything above the 1. All right, or we have t is less than -3, open circle, we'll shade everything above the below the -3. All right, so there's my solution to that compound inequality, all graphed out. Okay, there's also a part B to this in the note guide, so again, take a minute, pause the video, run through that compound inequality, and then check your answer before you move on. Now the last thing we're going to do in this lesson is go from some real-world situations to inequalities and solve them out. So let's show you an example of that. Problem 10 part A says a salesperson earns $200 per week plus a commission equal to 4% of her sales. This week her goal is to earn $450. Write and solve an inequality to find the amount of sales she must make to reach her goal. Okay, so classic business situation. I know how much I want to make. I have a base salary, okay, along with a commission, a percentage I make on each sale. And here I want to know how many sales I need to make before I get to $450. Okay, so setting this up, the easy thing might be to do is we want kind of the bulk of our expression to be greater than 450. And as far as the left side is going to go is we get the automatic 200. Okay, we're going to add to that 4% of the sales. So if sales is my S, so we say S for sales, the way I'll find 4% is I'll multiply by 0.04. Okay, a little percentage review, okay, times, okay, the decimal version of that's going to give you the actual answer. So there's our inequality. We want to solve that then. We want to solve that for my S. Okay, I'll try to figure out a way to make my S look less like a 5 as I go through here. To do that, we just got to hit S by itself. I'm going to subtract 200 from both sides. That's going to give me the 0.04 S is strictly greater than 250. So in other words, at this point, I can see that I need to make more than $250 in my sales commission. To get the S by itself, then I'm going to divide both sides by the 0.4. Whoops, 0.04. Okay, I wrote it right here. Said it wrong. Wrote it wrong here. They'll cancel out on the left, leave us with just the S is greater than that number of sales then. And if I take 250 and divide it by 0.04, I end up with 6,250. All right, so if I sell more than $6,250 worth of product or worth of sales or whatever we're selling here, that's going to leave me at or above my goal here. Now, I guess one thing as I'm looking at this, okay, it'll be tricky to be too picky with this on a test just because we're not super specific. But I guess I want to think about, do I want a greater than or equals to sign? And here it says, write and solve an inequality to find the amount of sales she must make to reach her goal. Okay, I'd say reaching is the same thing as equals. So I'm going to switch these all into a greater than or equal to. Okay, pretty simple fix at the end if you don't think about it till the end like I did here. Okay, so I'd say S is greater than or equal to the 6,250. All right, that's it for this video lesson. Now there is a part B, okay, another practice problem of doing real world situations. I'd say for sure give that a shot here and check your answer before you get into the Math Excel and start doing the individual practice.